Hey guys, this is a continuation of the Phantom V4 camera video. I've since had a little bit of luck getting it working. I tried the software, the current version of the software provided on the Vision Research website, and that had some odd effects. It was very surprising. It actually included Windows XP drivers when you installed it on a Windows XP system, and it found a Phantom V4 camera version, but it wouldn't connect properly. It would a video output on the NTSC would flash, and it wouldn't. You couldn't view any proper images. And while I was working with that, another problem came up. Was the camera seems to have some sort of intermittent connection, because if I just give it a couple of whacks, you see the image just offset. If I keep whacking it, it will crash. So there's clearly an intermittent connection inside the camera somewhere. It was especially crashing when I was wiggling the FireWire port, so I'm figuring it's potentially something on that board. So I'm going to pull it apart and see if we can figure out what's causing that. Okay, we'll start here just by poking around at these board-to-board connections. Oh. See if we can push on one of these and it will cause a problem. No. The RAM doesn't seem to be... Now it's sort of doing it by itself. Definitely, when I wiggle the this board, wiggle the interface board, it does it. Not so much, a little bit, when you wiggle the RAM boards. And now it just crashed. Try rebooting it. So the first thing I'll try is just going over all the contacts with connector contact cleaner and see if that clears anything up or makes it better. I just noticed the dummy connectors they put on this power board, I guess just for mechanical support, turned out to be misaligned. So I guess that's why they didn't fit those. Yeah, they messed up on the alignment there. They put them a little bit too far that way, and they couldn't fit them. And we'll just cycle that a few times. Hopefully push all the dirt out. I'm hoping it was something simple, like a little string of hot snot got in one of the pins and has caused an unreliable connection. But yeah, I'll just repeat this on all the other ones. Okay, we're still getting some weirdness. It's these lines on the screen. It looks sort of like the random data you'd find in RAM on power-up. At least now. Doesn't seem to be as sensitive to movement. I can probe around on it. It doesn't seem to crash. Let's try restarting that and see if it's any better. Although it's funny, it's now drawing more current than it was before. That's really odd. The current draw is going up very slowly to higher values. I'm going to try reseating those FFCs and see if that makes it any better. Looks like there's still an area where if I wiggle this board, and of course now it's not doing it for the camera, but when I was wiggling the FireWire board, it was, there we go. Doesn't seem to be the power supply board. I'm flexing that and it's fine. But when I flex, definitely, when you flex the one of these two boards, it crashes. Yep, seems to be this board. Yep, just tapping on that a little bit causes that. So that is the that's not the one with the FireWire. That's the other board. Now it's not doing it. So when I push down on that, it does it. When I don't, it doesn't. I'm definitely thinking it's something to do with the board-to-board connectors. Okay, this is interesting. When I give this board a slight, even the slightest flex, don't know if you can hear that, but it's audibly clicking, even on a tiny little flex. I'm thinking that cannot be right. I'm trying to figure out where exactly it's making that noise. I'm wondering if that's indicative of some sort of problem. Okay, after a whole bunch of playing around, I think I may have found something. Because when I squeeze the connectors between these particular boards, these two, one of the control board and the firewire board, it has the problem, but not particularly with the other boards. More also if I separate the boards a little bit and then cycle power to reset it, then it seems to come up reliably. You can tell because the clock is running, it's actually doing something. And then if we squeeze them back together, it has the problem. So I'm just going to go ahead and reflow all the connectors between these two boards and see if that does anything. Okay, let's see what that does. That's a better sign. At least it came on the first time. Dare I try to touch it now? That seems better. It's not crashing yet. Image is centered. Let's put a lens on. Yep, that all looks pretty good. So, after a whole bunch of debugging, I figured out what seems to be causing the problem. On each memory board there's a 4-channel DAC that adjusts the VREF value for the ADCs, or for each group of 2 ADCs. And for some reason, those are all being set to 0. And I've even checked the SPI bus on this, and they are indeed all being set to 0. All of these writes are writes to the DAC. And I'm not sure why they're writing 32 bits to it, but only the last 8 bits are the actual channel values, and those are all being set to 0. And it does seem to be correctly, this value here is the channel address. Those are being sent right, but the values are all 0. Having a DAC VREF of 0 explains this sort of weird image we're getting here. So I'm thinking that the whatever corruption has caused there's this weird garbled text under that number there. I think whatever's corrupted there has also corrupted the values for that DAC. So I'm gonna have to see if I can find the factory calibration file for this. It says in the manual Vision Research does have it. I'm gonna have to go off and ask, see if I can get it from them. It's been a couple of days now, and I was actually able to get the STG file I need to hopefully fix this. A huge shout out to Nathan from Aimed Research. They're a high-speed camera rental company, and he saw the last video on this camera and sent me the software, and just now sent me the file I need to hopefully fix this. And he's also sent a Phantom V5 for teardown, so it'll be really cool to see the next version up of this camera, how that's built and how that compares. Again, thank you very much for getting this. So let's restore the memory from file. Oh, and that looks like it has fixed it. Awesome. Okay. Yep, I think that's done it. Awesome. Now that that's working, I figured we'd have a probe around some of the signals in this and just see what some of the clock rates run at. So I've got two probes here on two of the 16 video channels, the first one on each board, and that's on the scope up here. And on the screen I've just got a vertical pencil so we can see, create a vertical line so we can see what's going on in the video. Which is something a little bit odd I noticed about this image sensor. Anyway, if we zoom in on this, if I just move my finger up and down, you can see this is up. So the first line is actually, the bottom line is read out first, which is a bit odd. I just decided to run it upside down. So if you look at, this is one whole frame we're seeing. If we move the, up and down, if we move this to the, if we look somewhere near the bottom, we'll see that vertical line. So here, that is one horizontal line of the video. So as we move that pencil around, you can definitely see that moving. If you look at the clock rate, let's just get some cursors up here. We have about 20 megahertz. That was around what I thought it was. And the one strange thing, if you count the number of pixels across here, you get 64. And if you multiply that by the number of channels, 16, you get 1024. But this image is 512 pixels wide. So what they must be doing, figured out what they're doing here, is if we just move, if we look at this very detailed, these pixels, you can see there's two channels here. You can't really see them much because they overlap. But they're reading, each board reads 8 pixels that are on top of each other. So what I would have expected is all 16 channels in one row to be divided up across the two acquisition cards. But what they've actually done is split it up, instead of 16 by 1, they split it up into 2 by 8. And the top row goes to one card, bottom row goes to the other card. So the benefit of this is you can decrease the resolution in smaller steps, in 8 pixels instead of 16. Although I would think this would require a more complex sensor, because you would have to have, instead of one readout line for every row, you have to have 2, because you have to be able to select one of 2 different pixels. I'm wondering if this is left over from the larger format sensor that they're using, and just when they're only using 1/4 of it. It'll be interesting to see in the V5 how this is different, if they've done the same thing or if they've arranged it in some other way. I suppose this also simplifies readout for displaying the live image. So instead of having to select between different cards as you read out one line, you only have to, you can read one whole line from card 1, the next whole line from card 2, and alternate like that. So it might simplify the logic somewhat. The last thing I'm curious about on this is what speed the RAM operates at. I've probed one of the data lines here, and that should give us a good view of what's going on. We're getting quite a nice eye diagram there. Let's just see what we got here. So this will be the period of one clock. So that's about 40 megahertz. Or 2 periods is, yep, pretty much exactly 40 megahertz. So twice the image sensor clock. Nice, clean, convenient divisor ratio there. For some fun test shots, I figured I'd set up the good old inverted lawnmower. If you saw one of my videos a few years ago, I did something similar to this, but I'd only had the much slower high-speed camera at the time. I have this recording as an overview. But you can sort of see why they did away with the square format video, because this is not really, most scenes aren't really square, they're usually some sort of rectangle. And unfortunately you can't set the resolution anything other than power of 2 increments, so we can't do something like 512 by 384 or anything more convenient like that. We have to go right down to 512 by 256, and that's a little bit too narrow. And we also have my camera running a lower resolution, 408 by 244 at 5,000 frames per second. That's sort of zoomed in more where the object will hit, and we'll start out just with a bottle of water. And I think we're ready. I'll start recording. Ask you if you want to delete the data in RAM. Yes. I have a trigger button inside set up so we can trigger both of the cameras to stop recording at the same time. And that's recording, that one is recording. Start this one. There we go. Water all over the place, so I would consider that successful. Let's check what we have on the camera. Press OK, and then it brings up this playback window. It's a little bit weird how you have to do that, switch between windows. Let's see if we can go find that video. There we go. Let's just play. Oh, look at that, look at all the dirt spray out where the water sort of washed it off. Then the bottle gets pushed back, looks like into the, where the grass gets spit out. One thing that's not obvious is how to easily go through the video. I can use these buttons to go frame by frame, but I want to use the keys on the keyboard, and there's no obvious way to do that, it seems. And to save, we just have to set the start point, so we'll pick it about there. Set the end point. Let's save it close to the end, and then save. And then you have to set the AVI frame rate, which does not remember between savings, which is annoying. And it only checks the space on the hard drive. I'm saving it to a separate drive. Saving is not at all fast. I think it's something between 5 and 7 megabytes per second, so it's around 20 to 30 frames a second or so. I would expect more from FireWire, which is capable of 400 megabits per second, which is about 30-some megabytes per second. I'd say the video from my camera is quite a bit more interesting just because the angle we took it at and the higher frame rate. You can see the blade come in and chop the bottom of the bottle off, and then it goes and hits the bottom of the lawnmower, and then it keeps going. Oh, that's so cool. There's one last problem I noticed with this, and that is, if we get rid of this playback window, if you go into the camera options, I can't change any of these settings, like the trigger edge. And in the newer version of the software that I tried, it would connect to the camera, sort of. It wouldn't download images properly, but I could change these options. So I'm suspecting something is up with the with this software, or it's some sort of interaction with the particular firmware version on this camera with the software. So if anyone knows what to do, how to get these options to work, please let me know, because I don't want to have to open the other version of the software just to change the trigger options. It says restart the FW camera to enable the... So something's clearly wrong here. I'm guessing FW is FireWire. Update doesn't do anything. Restarting the camera doesn't do anything. Yeah, I'm not sure what's going on. So I will call this camera pretty much operational now. At this point I just have to get the mating connector for this, which is about $55, but I guess it's worth it rather than doing this. And while I have this set up, I'll do a few more shots for you guys to enjoy. I was looking at the datasheet for this connector, and if you look in the bottom, wow, this has been in production for a very long time. Old military stuff.